Hey everyone, this is Dr. August de Oliveira. One thing I get asked all the time is which printer should I buy? And everyone who's seen my videos knows that as a general dentist, I tend to lean towards the Form 2 and the Moonray, and I get asked why. Well, the real question you always should be asking yourself before you're looking at a printer is, what do I need to print? Now, the way that 3D printers, I think, fit in the whole milling equation is that we should use milling for anything that's hard and permanent. So, final crowns, bridge frameworks, titanium abutments, zirconia abutments, anything that's permanent and hard should be milled. But what can be printed, it's usually plastic or stone. And there is a certain degree of resolution to both. So, if I'm using my 3D printer to make a night guard that has about 120 microns of spacer in it, then it really doesn't matter what the resolution is. I can have a Form 2 with 150 micron resolution or a Moonray with 100 micron resolution. If I'm starting to get into temporary crowns, temporary hybrids, if I'm looking at models that need dies and margins and implant analog models, you've seen me review printers like the Frozen, which is a great low-cost printer. But what comes with cost is a certain degree of lack of reliability. They tend to fail a lot more. So if I'm operating a lab and I need, restorations that fit dies, I need analog models and temporary hybrids, I don't have time for a print failure. And so there's a whole line of lab-based printers out there. If you've been in the printing world for a while, you probably know EnvisionTEC. EnvisionTEC is one of the primary DLP printing companies out there, and they have a line of printers with very high resolution that a lot of labs like. Another player is Asiga. Now, Asiga, there's a lot of things to like about this printer. One of the things that I really love about this printer is it probably has one of the highest resolutions out there, 39 microns in the XY. So it's really hard to beat that, and I actually don't know of a printer that beats that in this price point. So EnvisionTEC printers, the Micro Plus XL is actually very reasonably priced at $7,000. The EnvisionTEC Vita is in the $20,000 range. The Asiga is around $12,000, and this is the Asiga Max. So when you're dealing with printers that have a very small XY resolution, you also have to deal with a smaller build plate. The Asiga Max actually has a pretty decent size build plate. It's about 80 by 140. So it's a little bit bigger than an iPhone, definitely big enough to fit 2 models at a time. But one thing that I really love about the Asiga, which I think a lot of printing companies have kind of tiptoed around, is the Asiga is a completely open source printer. There's actually a wizard that will walk you through a test to develop a resin profile. For those of you that don't know what a resin profile is, a resin profile tells the computer in the printer, hey, how much light do I deliver? For how long, how strong should the build plate pull away from the resin vat. So there's a lot of information there, and I got to be honest with you, I'm not smart enough to actually figure out this stuff. I actually have a chemist who's developed resin profiles for the Wanhao duplicator and the Frozen. I cannot take any credit there, but this printer figures it out for you. So you enter in some data in and do a little bit of measuring, and it will figure it out for you. Other thing that's really cool about the Asiga printer is that it's really, really kind of robust. All the parts really snap in, and a completely disposable resin vat. So the resin vats are actually really pretty reasonably priced. I think they're about 80 bucks each. And you can use the same resin vat for any resin as long as you clean it up. One drawback about printers like the Form 2, that use a type of resin vat with a layer called PDMS. And PDMS is basically PVS impression material that's at the bottom of the resin vat. That PDMS can get soaked with different types of resins. So with the Form 2 printer, you need a different resin vat for every single resin. Not with this one. So with this one, you can use one resin vat for everything, and this is actually pretty common with the LCD and DLP printers. So I'm going to go ahead and cut, and we'll talk a little bit about the software with the Asiga Max, but overall, it's a great, actually I'm not going to cut. Let me go ahead and talk to you a little bit about some prints that I've done. So if you've seen my videos, you'll probably recognize this bridge. So this bridge is a laser sintered bridge. And this bridge is unique in that it really doesn't have a lot of spacer in it. So it's a super good way of testing the real accuracy of the printer. I mean, I can talk all day long about calibration cubes and all these types of things, but the bottom line is, when we have a bridge and we put it on a model, if I look at this, the space between the model and the bridge, so for those non-dental people, we call them the margins, this is a completely passive fit. This is completely closed and probably the most accurate model out there. This resin is got a great finish. It's a really nice matte finish. And just as an aside, if you're a dentist, you probably grew up with Whitmix. Whitmix got their name, for those non-dentists, from this really cool little vacuum mixer that we use to use our dental stones. And so Whitmix is the US distributor of the Asiga, and Whitmix has a line of resins. And I went to Louisville, or Louisville, as some people call it, and actually toured the Whitmix facility and talked to their chemists and talked to their engineers. And one of the coolest things I found was they were hell-bent on getting a resin that looks like their dental stones. So if you've used Whitmix stones, they've got like a blue, they've got a green, they've got a yellow, and they've reproduced those in their resins. So the Whitmix or the Asiga printer can use that. It can use the Nextent resins. They also have their own line of Asiga resins. The one thing that's interesting when you are evaluating bridges and whatever a test that you have is be careful for companies of making a bridge that has a lot of spacer. So this bridge has a ton of spacer in it, and this is going to fit really any model that you make. So my test is a little bit better. But the real test, really for, again, a lab or a dentist who's doing a lot of dyes and doing a lot of implant analog models, is if you can get an implant analog. I just dropped my die. But over here, it's hard to see. I'll try to hold this up. But we have a very nice, really exact fitting analog in this model. And I dropped my die because, and actually it's a great point to bring up, so exocad defaults to 100 microns of spacer between the die and the lateral walls of basically where the die fits. Name of the game is to get that spacer as small as you possibly can, and the reason why is the more space you have, the more movement you theoretically could have of the die. This is supposed to rival a Pindex die. And so I had that at 100 microns, and the die actually fit kind of loose. So I could actually go down in exocad to do it. But look, the real name of the game here is to get something that's going to make crowns fit really well. And if I could just get this to go on the die the way that I wanted to, well, whatever. It's on there really, really well. It's kind of hard to do it when you have a full die. But what you can see here, and I'm sorry if you guys can't see that too well, but we have a Cerac crown that we did on a patient, milled it out, it fits the die perfectly. So this printer, I highly, highly recommend if you are either a dental lab. If you're a dental lab, just yes, this is a great, great printer for you. Or if you're a dentist that does a lot of model work, this one is a great one. So I am going to cut now, and I'll go ahead and show you the printer and sort of my opinion on some 3D printing companies and their software. So talk to you later. Hey guys, back on the computer here. So I wanted to talk a little bit about Asiga Composer. So Asiga Composer is the software that runs the Asiga printer, and this is where I get on my soapbox a little bit. And if you look at the history of 3D printing, 3D printing started back in the day really with a printer no different than the Form 2, but how it got in the mainstream was through something called the RepRap project. RepRap stands for Rapid Prototyping, Self-Replicating Rapid Prototyper. In essence, it was a whole bunch of computer geeks, robotic geeks, and engineers across the world that sort of got together to develop the FDM printer for the masses. And so a lot of these printer companies kind of came from those engineers. And as a result, it's a really different sort of vibe than what you would get from CAD/CAM or even buying a computer or a phone. The way that most consumer-based companies work is they more or less expect us to be really dumb. And I don't mean that as insulting. It's actually a really good thing. One hurdle I see with companies like EnvisionTEC or Asiga and actually some of the other smaller printer companies like Frozen or even Wanhao, is that they expect the end user to be smart enough to get through the hurdles of the software or even the hardware. I mean, I can't tell you how many times I've bought a printer from a cheaper printer company and they're like, oh yeah, just, pop it open and solder this thing on. I'm not going to do that. I'm a dentist. I don't know how to solder. And we see the same thing with printer softwares. And I've been very critical in the past of these companies. I'll tell you right now that Asiga and EnvisionTEC are probably the best printers on the market with the worst softwares on the market. And I've been very vocal about this. The name of the game in any 3D printing and dentistry realm is to have a simple enough software so that you could basically have a non-dental person, your front desk person, or an assistant or whoever, get on a computer, stick a model in it, hit a couple of buttons, and get a print. So I'm going to go over Asiga Composer, and I've already talked to the folks at Asiga, and I've talked to the folks at EnvisionTEC as well, about what I think makes a good software. So let's go ahead and run through it, and I think you'll also see the limitations that I see. So we click Open, and it's just going to ask you to go ahead. I'm sorry, don't hit Open. We're going to hit New and start from scratch. So like most printer companies, we get a little menu that pops up that asks us what model material we're using and what slice thickness we're going to use. So Very model is made by Whitmix. We're going to be printing some implant aligner models, and we want to do that at 100 microns. So this is one step that I think that could also be sort of altered and put to the side. I like to get my models in there first, then I kind of want to think about what resin. So the right mouse button rotates, the left mouse button pans, the middle mouse button zooms. So we've got a little different sort of configuration than what most people are used to. We're going to go ahead and add some aligner models. This is not such a big deal. We'll go on the desktop and we'll find someone. And let's go ahead and select 2 aligner models and hit Open. So one pet peeve and a small step here is the models are just sort of thrown into the 3D space. So you can see here that the models aren't even on the build plate. I think that most people or most printer companies center the models in the center of the build plate regardless of sort of the orientation. So now I've got to go ahead and move it. So what you do is you click it and you get a bounding box. If you click it and just left click, the mouse kind of moves like this. But if you go ahead and put your button down. If you hold the button down till the mouse becomes blue, you can now move the model over. So again, mouse becomes blue and move it over. Again, this is sort of a redundant step. So now I've got models here, but look, they're not on the build plate. However, there is a cool step. So if you go to the top, there's this little icon that says auto place. And if you click that, it'll go ahead and put the models in the build plate in a sort of good orientation. Okay, so one thing that we commonly do in dentistry is print models flat on the build plate. Everyone has a different way of doing it. I will say it's a little wonky in the Asiga software. So what you have to do is click the model, come up to Tools, and click on Rotate Facet Downward. And then once you come over here, you can then click to make it horizontal. You can do the same over here. Tools, Rotate Facet Downward. And then now you have to do an additional step of auto placing them. And then they will go down, and now they're flat on the build plate. So as you can see, that there's a lot of other softwares out there that make things a little easier when we come to place. Now when we're ready to go ahead and print, we simply go ahead and click on Build. And this is, again, I hate to sound so critical, but we've got about 4 menus we have to jump through to get to it. So you can see here it's going to take us about an hour. We can put in batches of our resin to make sure that the resin is working well. I think it's pretty unnecessary. It's going to ask us, do you know that you're not having support structures? You hit continue. And now you can finally go ahead and print. Now, one thing that's really pretty cool about Asiga is Asiga has the option of actually building a little house. So let's go ahead and go on this little house. I think it is called Generate Multi-Stacking. And we go ahead and hit Apply. And you can see here that now we have another platform. Now we'll have to build structures that go underneath that. But you can see here that we can now build another layer and build another layer. What that does is it gets over the fact that we have a relatively small build plate. Now look, that's really, really cool. However, I can see a number of problems with it. One, I'm going to have to generate this sort of shelf and supports for the shelf. That's going to cost money. But think about this. Everyone is obsessed by printing vertically. And I print all my models horizontally. Why is that? Well, let's think about this. When we have a print failure, where is the print failure? The print failure is in between the bottom of the resin vat and the build plate and that layer not sticking. Now, if I print a model horizontally, I've got very little slices. But if I print a model vertically, I've got a lot more slices. Well, imagine with this, I'm printing vertically and then printing vertically again. So again, there's a ton of cool features in the software. I just think it's a little unnecessary. So overall, I think the Asiga is probably the most accurate printer on the market. It's a little more expensive at $12,000 than the Form 2 and the Moonray. Again, if you're a dental lab or a dentist that prints a lot of models, this is a great option for you. I'm still going to stick to my guns and say that if you are a general dentist and are printing guides and printing dentures, this would definitely work for you. But the Moonray and the Form 2 may be a less expensive option. So thanks a lot, guys.